Assalamualaikum warahmatullahi wabarakatuh. I'm Nur Natasha binti Edi and my group members are Nur Alia Maisara binti Abdul Rahman and Nurul Aisyah binti Abdul Rashid. Today we are going to talk about laboratory report, experiment 5, frictional force. The objective of this experiment is to determine the coefficient of static friction of the different surface. And also I'm going to talk about the introduction. Friction is the force that opposes the relative motion or tendency of motion between two surfaces in contact. It plays a crucial role in everyday life, enabling activities such as walking, driving, and holding objects. Frictional force can be divided into two types. That is static friction. Static friction can prevent an object from starting to move when a force is applied, and kinetic friction will oppose the motion of an object already in movement. This experiment aims to explore how the frictional force is influenced by the normal forces acting on an object. By varying the weight applied to a block and using the different surface material, the study will examine how this factor affect both static and kinetic frictional forces. Moreover, the experiment will calculate the coefficient of friction for various surfaces, offering insight into the characteristic of the material in contact. I'm also going to talk about the theory. Friction is force that receives the relative motion or tendency of motion between two surfaces in contact. It acts parallel to the surface and opposes the movement. Friction arises due to the microscopic irregularities and intermolecular forces between the surface. It is a fundamental forces in nature and play a crucial role in many everyday activities. Static friction prevents an object from starting to move when a force applied. The maximum static friction is given by Fs max equal to Un, where Us is the coefficient of static friction and N is the normal force. Kinetic friction acts when an object is already moving relative to another surface. Kinetic friction is generally less than static friction. The kinetic frictional forces is given by Fk equal to Un, where Uk is the coefficient of kinetic friction. The apparatus that we use in this experiment is wooden block, rubber covered at one side, and 50-gram mass, and 10 Newton spring scale, string and tabletop. Right now, this slide is showing the picture of apparatus setup in this experiment. Procedure of this experiment is, the first one is, the mass of the wooden block was measured and recorded as M. The second one is, the apparatus was set up as shown in figure 5.2. The third one is, the tabletop was ensured to be stable and horizontal to the ground. The next one, the spring scale and the wooden block were attached using a string and placed horizontally on the tabletop. The rubber side of the block was ensured to face downward. The next one, a mass of M equal to 50 gram was placed on the wooden block. The next one is, the spring was pulled slowly, and once the block started moving, the spring scale reading was recorded as Fs and tabulated in table 5.1. Step 4 and step 6 was repeated for 3 trials. The second last one is, another 50-gram mass was added to the wooden block, and step 5 to step 6 were repeated. This step will repeat until a total mass of M equal to 500 gram was placed on the wooden block. The last one is, step 1 to 8 will repeat, ensuring that the rubber side of the block was faced upwards. The data were tabulated in table 5.2. This slide is showing the mass of the wooden block with rubber. That is M equal to 78.3 plus minus 0.1 gram. The next slide is also showing the mass of wooden block without rubber. That is M equal to 87.0 plus minus 0.1 gram.
Hi, my name is Nur Alia Maisara binti Abdul Rahman. My student ID is 2024256914. Right now, I will explain the free body diagram of a wooden block on two different surface. On the left, the block is a non-rubber surface. We see three forces acting. The applied force to the left, the weight acting downward, and the normal force acting outward. On the right, the block is on a rubber surface. Here we see an additional force of friction, which opposes the applied force. This comparison highlights how the type of surface affects the force acting on the block, especially the role of friction. This slide shows how to calculate the coefficient of static friction for each surface using the gradients obtained from the graph. The goal of this analysis is to determine the coefficient of static friction for the surface, rubber and non-rubber. This is done by using the linear relationship between the static friction force and the normal force. The equation of static friction is Fs equal to mu s, and this equation corresponds to the form where y equal to ms plus c, where m equal to mu s and c equal to 0. From the graph, Fs is plotted on the y-axis, and then n is plotted on the x-axis. To calculate the gradient is determined using the formula m equal to y2 minus y1 divided to x2 minus x1. From the calculation, the results show that rubber surface is 0.0815, and for the non-rubber surface is 0.041. The conclusion is the rubber surface has a higher indicating greater friction compared to the non-rubber surface. This difference is due to the material property of rubber, which creates more grip compared to the smoother non-rubber surface. I'm going to compare and discuss the coefficient of static friction we obtained. The coefficient of static friction used for the rubber surface is 0.0815, which is higher than that of the non-rubber surface at 0.041. This indicates that the rubber surface offers greater resistance to motion compared to the non-rubber surface. In this experiment, we observed and know that rubber has more high frictional properties when it contacts with hard surface. For example, like table itself. As a result, it requires more force to initiate movement compared to the non-rubber surface.
First question is, how can anti-lock brakes stop a car in a shorter distance than regular brakes? Anti-lock braking system prevent the wheel from locking up and skidding during braking by rapidly modulating the brake pressure. This ensures that the tires maintain their grip on the road surface. Next is, from your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determines the coefficient of static friction? From our experiment, the block with the rubber surface has the highest coefficient of static friction because it is less slippery. This aligns with my hypothesis. The more rubber is added to the block, the higher the coefficient of static friction becomes. I believe the surface properties of an object determines the coefficient of static friction, as less slippery surface result in a higher coefficient of static friction. Next question is, once a mass begins to slide, does it move smoothly, or does it undergo stop and go motion? Explain the motion. The mass moves in a stop and go motion. The wooden block rubs against the floor, creating friction. This friction prevents the block from moving freely, resulting in a slow-paced movement until it comes to a natural stop. We already made a discussion for this experiment. Frictional force is the resistance created when two surfaces come into contact and slide against each other. The experiment revealed a distinct difference in the coefficient of static friction between rubber and non-rubber surface. This difference exists because surfaces that resist sliding typically have non-rubber surface. The rubber surface is flow, which increases the resistance against the flow. On the other hand, the non-rubber surface was left unaltered, making it smoother. As a result, when the string was pulled, the wooden block with the non-rubber surface moved more easily, leading to a lower coefficient of static friction. During the experiment, various sorts of error could have impacted the result. For example, instrumental errors might have occurred if the stand and spin scale was not properly calibrated before use. Additionally, procedural error could arise if the wooden block was not pulled uniformly, requiring precise control to ensure consistent movement with minimal force. Human factors may have contributed to inaccuracy in data collection. Lastly, to minimize random error, multiple trials were conducted and the average value were used to obtain more reliable results. In conclusion, the experiment demonstrates that the coefficient of static friction varies between rubber and non-rubber surface. The rubber surface exhibits a higher coefficient of friction due to raw texture, which creates more resistance against sliding. In contrast, the non-rubber surface being smoother resulted in a lower coefficient of static friction, while potential source of errors such as calibration issue with the spring scale and inconsistency in applying force could have influenced the result. The use multiple trials and averaging helped mitigate random error. Overall, the experiment highlights the importance of surface texture in determining frictional force and the need for careful experimental technique to ensure accurate measurement.
That's all from our group. Thank you for watching.